Good morning, everyone. I'm going to go over a couple of videos here. The first one's going to be just a quick summary of what we saw yesterday. Essentially, you were asked to graph an original function and its reciprocal using some graphing tools so that you can get a good look at the two graphs and kind of make some comparisons. So I'll just quickly summarize the key points there. These will give us the opportunity to do some sketching when we can draw the original. Today we'll get into some sketching when maybe the original is not that easy to draw or when it's not quite so obvious, but it's good to know both. Sort of the understanding of what a reciprocal is kind of comes from this first activity. So I've sketched quickly at y equals x squared minus 4, or f at x equals x squared minus 4 off to the right side of the screen. And I'm looking to basically do this one, the reciprocal. So some of the key ideas, the first thing to recognize is what we're doing in all cases is we're taking the g at x, let's say, looks like this. It's 1 divided by whatever the values were before. And again, this is the old y values. So we're taking whatever our old y values are and dividing 1 by those numbers. That's just the definition of reciprocal. So in going through that then, if we think about some of the key points, the zeros, first of all, when y is equal to 0, so these two spots here and here, what happens is, if we actually divide 1 by those zeros, we get an undefined value. Error. Which means that those two spots on the graph, actually let's use the green. Those two spots on the graph are spots where my new graph cannot pass. That's how we get our vertical asymptotes. Okay, so vertical asymptotes occur basically when we have a division by 0. If I'm looking at this one, oops, if I'm looking at this, of course, it should be pretty obvious that when I put x equal to 2 or x equal to negative 2 into here, that's when I get a problem. And I get division by 0, and so that's why we end up with the vertical asymptotes at those two spots. We can make these straighter. Not important. Continuing on then, a couple of other interesting and fairly key points. When y is 1, we end up with 1 divided by 1, and of course that's still going to be 1. So y is 1 kind of, let's say right about here. Not a really well drawn graph obviously, and right about here. Which means that on my new graph, I will have those same 2 points as well. And again, the reasoning for that is pretty simple, right here. If I'm taking whatever my original was and dividing 1 by that, 1 divided by 1 still gets me the same value. Same thing with the reciprocal, reciprocal when y is negative 1. So somewhere right around here. I've got a couple of negative ones. Sorry, I keep slamming that. Switching pens. And so I'm going to have those same 2 points again on my new graph. Last thing that we saw yesterday, or the last key thing, you might have noticed a few other things, but these are sort of the ones that I pull out. Anytime our graph is increasing in the one case, in the original, it'll be decreasing in the second. And again, over here in red is my reasoning for that, or my explanation, is that when you divide by bigger and bigger numbers, you end up with smaller and smaller answers. Same thing going the other way. If it was decreasing originally, it should be increasing afterwards, because as I divide by smaller and smaller numbers, I get bigger and bigger answers. The last thing of importance was sort of the horizontal asymptotes, and we didn't really see those or necessarily know how to deal with those. Now my my graphs are pretty poor here. I'm just realizing this one should be a little bit more obviously not touching that point. But so basically that's what we're going to look at today, and sort of to realize where those asymptotes come in. I know where they happen to be. That's what I'm looking for. I know where the horizontal asymptote happens to be because we dealt with it yesterday, but sort of why it comes up in a specific spot is really going to be our key. In this one, the horizontal asymptote is a spot where I won't hit. It's a y value that I won't get to. And the only one that I can't get, the only number I can never get when I divide 1 by some other value, okay, so sort of looking here, I'm pointing to the screen right now and you're not seeing that because you're not here with me. But looking at that equation, when I divide 1 by anything, I can get pretty much any number other than 0. And so from that logic, the horizontal asymptote was 0. And what that tells me is I need to hit these 2 points, this one and this one, without crossing these 2 vertical asymptotes. But at the same point, I can't get to that spot. So I'm pretty much going to have this kind of an idea in the middle section here. Over here, I'm going to hit this spot somehow, but I can't hit this line, and I can't hit that line, and so just a little bit of reasoning here tells me that that's what my graph's going to look like. The only other thing that I probably should do, or we will be doing, would be, it would be nice to know what this point right here is, kind of a key point, the y-intercept. And so that's something that I think that the chart actually had you find or asked you what it was. If it didn't, then it's going to be a key point that we will find just because it's kind of nice to know. So x-intercepts, y-intercepts for our graphs will always be nice. Sometimes, obviously, in this case, we don't have any x-intercepts in our new graph, in our reciprocal. But that's good to know as well because, of course, it means that there's a horizontal asymptote at that spot. Okay, so that's kind of the idea that if I have a graph and I know I'm looking for the reciprocal specifically, I can just sort of do some logic here and say, well, if there was a 0 there, I have a 1 over 0, which means obviously an impossible spot to hit in the graph, a vertical asymptote. 1 divided by 1 doesn't change, negative 1 divided by negative 1 doesn't change, and then if I'm increasing, I should be decreasing, and so on. So that's kind of a summary. I'm going to stop the video there, and then I'm going to give a kind of a more formal look at sort of a more general approach to solving these.